Okay, let's look at this question again. 10.1. During COVID-19 pandemic, researchers conducted many studies to test the effectiveness of various vaccines. The table shows the data of one of these studies. In this contingency table, dealing with male. Remember, when you go right from here, we get the total for males. We go right from here, get total for males. So these are male, these are female, they are total. Go down, we get total for those who are positive. We go down, we get total for those who are negative. Altogether, the total of everyone who was tested. Okay. Now here, this 27 is for males who are positive, males who are negative. These are males who are negative. These are males who are positive. This is female who are positive. These are females who are negative. So this is just negative. This is just negative. This is just positive. This is just males. These are just females. So this is where we talk about the intersections. But here, it's just, okay, whatever, we'll see. 10.1. Probability that the random selected participant is a female. So let's look at 10.1.1. Probability of a female. How many are females? 648 out of 864 are females. So we're going to say 684 divided by 864 are females, which this makes them 3 over 4. 3 over 4 is a probability of choosing a female. 10.1.2 is the probability of testing positive for COVID-19 independent of gender. Now I said the probability of being positive, is it independent of the probability of being a gender? Now remember, if the answer is yes, and the probability of being positive multiplied by probability of gender should be probability of being positive and gender. But if the answer is no, probability of being positive multiplied by probability of gender, probability of supposed to being positive, and you should think about this before you answer the question. This is one of the motivate your answer. This way we get the motivation of the answer. Now let's look at this. We're dealing with the probability of being positive. So I mentioned that there are those who are positive, probability of being positive in this situation. What way is the positive? This is positive. Regardless of the gender, this is positive. So let's check out how many positive. Positive of choosing one was positive. But here we looked for female. So that's just, let's go and deal with the probability of being a female. Probability of being a female, which is 3 over 4. But probability of being positive is 108 divided by 846. Which is 1 over 8. 1 over 8. So now we're going to say, now probability of being positive multiplied by probability of being a female, which is going to be 1 over 8 multiplied by 3 over 4, which this is 1 over 8 multiplied by 3 over 4, which this makes it this 3 over 32, or which is make it 0.09375. Now let's look at probability of being positive and a female. Okay, positive and female. This is also positive and female. It's positive and female, this one. So it's going to be 81 out of 684. Yes, 81 not 18. 81 over 864, which is 3 over 32. which is the same as 0.09. So our answer is yes. Probability of being positive multiplied by probability of gender, which is a female, it is equals to probability of being positive and a female. So when we talk about gender here, we're given two genders. Even if you can use gender as a male, as a gender, and positive, you will find the same answer.